Hello, in this video we'll be walking through looking at a dataset in order to identify a difference between classes so that we can define a metric for any fault that we've discovered. First, we're going to load a file from our dataset. This will introduce the available curves and buffers to ANOVUS. Then we can create a viewer to look at our data. We can select a buffer of interest. If we have many buffers, we can use this Hide Empty Buffers option to just view the ones with data. Once we've selected a buffer, we can click Analysis. This will create a new analysis viewer. We can add our data to it by right-clicking and going to the class editor. Then using the Add button, we can select our files that we want to analyze. If we know in advance which of our data sets are going to be differing, we can move them to a different class. However, if we don't know this in advance, we can look at our data in order to find out which curves would be in which class. Zooming into the data, we can notice a few discrepancies. If we press and hold the Alt key while selecting a point on a curve, we can have it be highlighted in our class editor. This will allow us to identify which curve is which so that we can move it to a different class. Now we can see a clear separation between the curves from one class type and the curves from another. The gap in between the two is shown in the bottom plot, where if a value from a class 1 curve is in between the maximum and minimum of class 0, then we have no gap, whereas if it's outside of all of the class 0 curves, we will see the gap of the smallest difference between the two. Here we have the gap between the largest of class 0 and the smallest of class 1. We can also change which statistics are displayed by right-clicking and going to the viewer settings. This allows us to choose whether we're showing the gap, standard deviation, difference relative to the tolerance, or the range of the curve. We can also change our top display in order to view the general trend. For example, if we want to look at the mean plus or minus 1 standard deviation, we can change it to a statistics view. Once we have identified our curves between two classes, we can find a notable point to decide whether to use it for a metric. For example, this area has a very clear distinction between the curves, more so than the peak here at 12 order. We can position our cursor at the desired location, here at 10 order, in order to see the mean, maximum, and standard deviation of both curves. This allows us to calculate whether a metric is viable. For example, here, our highest blue value is at 111.6, while our lowest red is up at 117.5. Since there's a very small spread within each class, we can use this to make a metric that has a low variance. For example, if we were to define a cutoff in between the two curves, we could use the processing capability index in order to discern how likely it would be for us to have false negatives or false positives. This index takes the difference between the chosen cutoff and the mean value and divides it by 3 standard deviations. If we assume a standard normal distribution, then a value of 1.6667 would correspond to 5 standard deviations from the mean, which is going to be having a likelihood of only 1 part per million of false positive. Using the statistics that we can see in the legend, we can calculate our false negative and false positive likelihood if we were to choose a cutoff. For example, if we were to go about 114 here to cut between the two curves, we can calculate what our limits are going to be. For our false positives, which is likelihood of our blue class 0 being above the cutoff, we use the class 0 statistics. So if we take our upper bound, and subtract our mean to get the difference, which is coming from the legend here. Then we divide this by 3 standard deviations, which again is located here in our legend. Our result is 3.2688 sets of 3 standard deviations away from the mean, which means that we have a very, very low likelihood of getting a false positive. Similarly, we can check for false negatives by seeing how many of our class 1 curves are going to be likely to be below the cutoff. Since we're going to have a lower bound now, we're going to be subtracting the bound from the mean instead of vice versa. This gives us an even higher number, which means that we're even less likely to have a false negative. Overall, this means that if we were to place a bound limit at 114, it would be very likely to identify the curves correctly. Now that we've decided on what our bound is going to be, we can implement this using the ANOVA signal processing. First, we load the measurement setup that was used to gather this data. Now, since we're going to be making changes and then reprocessing the data to view the effect of our new statistic, we're going to want to save this file as a new .ams file. This way, our newly processed results will not overwrite our original results. Now, we're going to load the parameter that we want to apply this metric to. In this case, we're using orders. We can double-click on an existing item. That way it will pull up the existing trigger settings. We can effectively clone this set of settings by giving it a new name and using the add instead of change. In this case, we're only looking at one value, so we will keep the only feature A option. The value that we're going to be looking at is at 10 order here. Then our upper bound that we selected is 114. We're not going to set our lower bound to 0. This way, if we do have any unusual data, it will still be registered. Now that we've added this metric, we can reprocess our data. Using the measurement offline signal replay, we can load the ASD files that the original AME files were processed from. Pressing the start when we have the increment automatically box checked will go through all of the data and reprocess it. Once all of the items are done, you will get this completed message at the status bar. Now I can open the new results back in our signal analyzer. We're going to open one of the new results, which now, because we gave a new name to our .ams file, will be stored in a new folder instead of overwriting the original data. Now that we have this open, we can load it as a buffer as before, but this time we're going to select our new metric. Similar to before, we're going to add our curves in the class editor. If you have the curve saved in a file list, you can also add the list together using the Load List button. Now, we may notice that we currently can't see any data in our plot. This is because our y-axis hasn't automatically been scaled. We can right-click and go to the viewer settings, then check on the auto scale and the level so that we can see our in-between dividing line. Now we can use the sort button, which will take our metric, find which items had the OK or not OK value, and automatically use that to sort them from one class to another, so that we don't need to manually look for which curve is which. I'm going to designate these as going into class 1, And once I do so, these curves are automatically moved over, and you can see that our histogram is updated, where all of our class 0 1s are in blue and all of our class 1 are in red.